The National Electrical Code, referred to as NEC, requires that each dwelling unit have its own electrical service and meter. The minimum ampacity of the service is determined by the load calculations for the unit. To determine the required ampacity, one needs to calculate the estimated electrical load for each apartment. This involves considering the appliances, lighting, and other electrical equipment that will be used in each unit. The total ampacity of the new service should be greater than or equal to the sum of the apartment load calculations. Each apartment should have its own electric meter and electrical panel. The amperage rating of the new panel should be based on the load calculations for each apartment. The inspector will determine the specific ampacity requirements for the panels and meter based on the code and the load calculations. Here is a general procedure you can follow. Firstly, calculate apartment loads. Determine the estimated electrical load for each apartment using NEC load calculation methods. Secondly, determine total building ampacity. Sum up the apartment load calculations to determine the total ampacity required for the building. Thirdly, contact the electric company to request an upgrade to the service entrance for the total building ampacity. Fourthly, provide calculations to the inspector. Provide the load calculations and proposed service upgrade details to the inspector for review and approval. Fifthly, obtain a permit. Obtain a permit from the local building department before starting any electrical work. When calculating the electrical load for each apartment, several factors need to be considered. Firstly, general lighting load. The NEC specifies a minimum lighting load based on the square footage of the apartment. This ensures there is adequate capacity for general lighting needs. Secondly, small appliance circuits. The NEC requires a minimum of 220 amp circuits for small appliances in the kitchen and dining area. These circuits are intended to serve countertop appliances such as toasters, blenders, and coffee makers. Thirdly, laundry circuit. If the apartment has a laundry area, a dedicated 20 amp circuit is required for the washing machine. This circuit should not serve any other outlets or appliances. Fourthly, individual appliances. Larger appliances such as refrigerators, ranges, dishwashers, and air conditioners require individual circuits. The ampacity of these circuits should be based on the appliance's nameplate rating. Fifthly, heating and cooling equipment. The electrical load for heating and cooling equipment can be significant. It is important to accurately calculate the load for these systems to ensure the service has adequate capacity. Sixthly, electric vehicle charging. If the apartment building offers electric vehicle charging, the electrical load for the charging stations needs to be included in the load calculations. The NEC provides specific requirements for electric vehicle charging circuits. Once the electrical load for each apartment has been calculated, the next step is to determine the total building ampacity. This involves summing up the load calculations for all of the apartments, as well as any common area loads such as lighting, elevators, and HVAC systems. The total building ampacity is the minimum ampacity required for the service entrance. After determining the total building ampacity, the next step is to contact the electric company to request an upgrade to the service entrance. The electric company will need to review the load calculations to determine if the existing service is adequate or if an upgrade is required. If an upgrade is required, the electric company will provide a quote for the cost of the upgrade. Before starting any electrical work, it is important to obtain a permit from the local building department. The building department will review the plans and specifications for the electrical work to ensure they comply with the NEC and local codes. The permit also allows the building department to inspect the electrical work to ensure it is installed properly. It is recommended to consult with a licensed electrician to ensure the upgrade complies with all applicable codes and safety standards. Licensed electricians have the knowledge and experience to properly design and install electrical systems in accordance with the NEC and local codes. They can also help to identify potential safety hazards and ensure the electrical system is safe and reliable. The NEC provides specific requirements for the ampacity of conductors and overcurrent protection devices. Conductors must be sized to carry the calculated load, and overcurrent protection devices must be sized to protect the conductors from overload. The NEC also provides requirements for the installation of ground fault circuit interrupters, referred to as GFCIs, and arc fault circuit interrupters, referred to as FCIs. GFCIs are required in wet locations such as bathrooms and kitchens to protect against electric shock. FCIs are required in bedrooms and other areas to protect against arc faults, which can cause fires. The NEC is updated every 3 years, so it is important to stay up to date with the latest requirements. The NEC is available for purchase from the National Fire Protection Association, referred to as NFPA, and other sources. Many jurisdictions also have local amendments to the NEC, so it is important to check with the local building department to determine the specific requirements in your area. Upgrading the electrical panels and metering in an apartment building can be a complex project. It is important to carefully plan the project and follow all applicable codes and safety standards. By working with a licensed electrician and obtaining the necessary permits, you can ensure the project is completed safely and properly. The importance of consulting with the local utility company cannot be overstated. The utility company's requirements for service upgrades and metering can vary significantly depending on the location and the existing infrastructure. Factors such as available transformer capacity, service voltage, and metering configurations can all impact the design and cost of the electrical upgrade. By engaging with the utility company early in the planning process, potential issues can be identified and addressed proactively. This can help to avoid costly delays and ensure a smooth and successful project. In addition to the NEC, local codes and regulations may impose additional requirements for electrical installations in apartment buildings. These requirements can vary widely depending on the jurisdiction and may address issues such as emergency lighting, fire alarm systems, and accessibility. It is essential to research and understand the local codes and regulations that apply to your project to ensure compliance. This may involve consulting with the local building department, fire marshal, or other regulatory agencies. Proper grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to return to the source, helping to prevent electric shock. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of stray voltage. The NEC provides detailed requirements for grounding and bonding, and it is important to follow these requirements carefully. The selection of appropriate overcurrent protection devices is essential for protecting the electrical system from overload and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC provides guidance on the selection and sizing of overcurrent protection devices, and it is important to choose devices that are appropriate for the specific application. Proper wiring methods are crucial for ensuring the safety and reliability of the electrical system. The NEC specifies different wiring methods for different applications, and it is important to choose a wiring method that is appropriate for the environment and the type of load being served. Factors such as temperature, moisture, and physical protection should all be considered when selecting a wiring method. The installation of electrical equipment must be performed in a neat and workmanlike manner. This includes properly supporting and securing cables, making connections in approved enclosures, and labeling all circuits and equipment. A neat and workmanlike installation not only looks professional but also helps to ensure the long-term reliability and safety of the electrical system. It is important to thoroughly inspect the electrical installation after it is completed to ensure that all work has been performed in accordance with the NEC and local codes. The inspection should include checking for proper grounding and bonding, verifying the correct size of conductors and overcurrent protection devices, and ensuring that all connections are tight and secure. Any deficiencies identified during the inspection should be corrected before the electrical system is energized. Electrical safety training is essential for anyone who works with electrical systems. Training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Employees who are not properly trained can be at risk of electric shock, burns, and other injuries. Regular safety meetings and refresher training can help to reinforce safe work practices and keep employees up to date on the latest electrical safety standards. Personal protective equipment, referred to as PPE, is essential for protecting workers from electrical hazards. PPE can include items such as insulated gloves, safety glasses, and arc-rated clothing. The type of PPE required will depend on the specific task being performed and the potential hazards involved. It is important to inspect PPE before each use to ensure that it is in good condition and that it provides adequate protection. Lockout/tag-up procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned back on. Lockout/tag-up procedures are essential for protecting workers from electric shock and other injuries. Electrical safety audits can help to identify potential hazards and ensure that the electrical system is in compliance with applicable codes and standards. Audits should be conducted by qualified professionals who have experience in electrical safety. The audit report should include recommendations for correcting any deficiencies identified. Regular electrical safety audits can help to improve the safety of the electrical system and reduce the risk of accidents. In conclusion, upgrading the electrical panels and metering in an apartment building is a complex project that requires careful planning and execution. By following the guidelines outlined in the NEC, consulting with the local utility company, and working with qualified professionals, you can ensure that the project is completed safely and properly. The National Electrical Code, published by the National Fire Protection Association, is the most widely adopted electrical code in the United States. It provides comprehensive requirements for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It is important to stay up to date with the latest edition of the NEC to ensure that your electrical work complies with current standards. Article 220 of the NEC covers load calculations for electrical systems. This article provides detailed methods for calculating the electrical load for various types of occupancies, including dwelling units. The load calculation methods in Article 220 take into account factors such as the size of the dwelling unit, the number of appliances, and the type of heating and cooling system. Article 230 of the NEC covers service entrances. This article provides requirements for the installation of service conductors, service equipment, and grounding electrodes. The service entrance is the point where the electrical system connects to the utility company's power supply. Article 240 of the NEC covers overcurrent protection. This article provides requirements for the selection and installation of overcurrent protection devices such as circuit breakers and fuses. Overcurrent protection devices are designed to protect electrical wiring and equipment from overload and short circuits. Article 250 of the NEC covers grounding and bonding. This article provides requirements for the grounding of electrical systems and the bonding of metal parts. Grounding and bonding are essential for electrical safety, as they help to prevent electric shock and reduce the risk of fire. Article 310 of the NEC covers conductors for general wiring. This article provides requirements for the selection and installation of conductors for various types of applications. The ampacity of a conductor is the maximum amount of current that it can safely carry. The ampacity of a conductor is determined by its size, insulation type, and installation conditions. NEC Table 310.16 provides ampacity ratings for various types of conductors. Article 408 of the NEC covers panel boards. This article provides requirements for the construction, installation, and wiring of panel boards. Panel boards are used to distribute electrical power to branch circuits. The NEC requires that panel boards be installed in readily accessible locations and that they be properly labeled. Article 430 of the NEC covers motors and motor circuits. This article provides requirements for the installation and protection of motors and motor circuits. Motors are commonly used in apartment buildings for applications such as HVAC systems, elevators, and pumps. Article 440 of the NEC covers air conditioning and refrigeration equipment. This article provides requirements for the installation and protection of air conditioning and refrigeration equipment. Air conditioning and refrigeration equipment are commonly used in apartment buildings to provide cooling and heating. Article 550 of the NEC covers mobile homes, manufactured homes, and mobile home parks. This article provides requirements for the electrical systems in mobile homes, manufactured homes, and mobile home parks. While not directly applicable to apartment buildings, some of the requirements in Article 550 may be relevant to multi-family dwellings. Understanding the relevant articles of the NEC is essential for ensuring that electrical work in apartment buildings is performed safely and in compliance with code.